Domain and range. So domain is when I talk about any possible x values, and range is when I talk about any possible y values. When data is discrete, that means it can be counted. This would be discrete, this would be discrete, this would be discrete, and this would be discrete, because I can actually count the points. Versus continuous is when data can be measured. So it covers like anything between like 1, 2, 3, 4, 5. And so that would be like these last two graphs. So when we write domain and range for discrete data, we're listing points. So in this case, since domain is my x and range is my y, the domain would be 1, 2, 3, 4, and 5. Where the range, which is my y values, and we generally write them in like smallest to largest, so -2, 1, 4, 7, 10. So let's look at the next one. Domain and range again. So domain is x, range is y. Points are written as x, comma, y. So all the first numbers in my points are x's, domain, and all the second ones are my range. So I would have 2, 5, 7, and 8 in my domain. In my range, I would have 3, 4, 7, and 9. These y values right here. So let's look at the graph, a discrete graph. Still listing points because it's not continuous, it's not a fluid motion. I'm looking at my x-axis for domain, so that would be these numbers right here. And I have a point at 1, a point at 2, a point at 4, and a point at 5. When I look at my range, I'm looking at my y-axis. So I have a point at 1. I don't have one at 2, but I have one at 3, 4, and 5. Let's look at a mapping. When I have a mapping, I'm mapping my x values to my y values. So my domain would be 7, 9, 11, 13, and 23. Whereas my range would just be 17, 54, and 108. So let's look at some continuous data. So on your graph, I'm not sure if your little parabola has arrows at the end, but it should. So if it doesn't, fix that. Now when I'm talking about domain and range on a continuous graph, I need to try to box in what I'm graphing. This is going to keep on going out and out and out, so I can't box that in, but I know it's not going to go any farther than this. And I don't know how tall it's going to go. So if I'm looking at the domain, which is the x-axis, how far left can it go? Well, this is going to keep on going and going and going, so it could go on forever, or what we call infinity. And I know that my x value has to be somewhere in between negative infinity going out this way and positive infinity going out the other way. So then let's look at our range. So the range is how low I can go and then how tall it goes. So the lowest my y values go is this -9. And it actually touches -9, so we say less than or equal to. And then I know my y values can keep on going up and up and up forever and ever, so this would be infinity. All right, let's look at the last continuous. This one is a little bit different. It doesn't have arrows saying it's going on and on forever, so I am going to box in my picture. So this helps a little bit because I can tell how far left and how far right I can go, how far down and how far up I can go. So if I'm looking at how far left I can go, because I know domain is going left and then right, I notice that it goes to a +1. And this +1 has an open circle, so that means I'm just going to use the less than symbol. And then I look and see how far right it can go. Well, it goes all the way out until 4. And I see that 4 is a closed circle, so it's going to be less than or equal to. So now let's look at our range. I know range is how far down it goes and how far up it goes. So the lowest down it goes is 1. And I see that that's an open circle, so it's going to be a less than symbol. And then I put y, and then I see how far tall it goes, and that's at 7. And that's a closed circle. So that's going to be less than or equal to.